Area. The area is the amount of space inside boundary of 2D shapes. What is the concept behind calculating area? We have taken up a tiny square which could have any measure like 1 by 1 foot or 1 by 1 meter or any unit. Now we take up these small squares and fit inside the bigger square to check that how many small squares we need for this big square. If the small square was 1 by 1 foot, then we can say that this square is 9 square feet because there are 9 squares that fit inside this bigger square. If length and width of a small square is 1 centimeter, then we can say that it is 1 square centimeter. We can also write it like 1 square centimeter. If you have a tile that is 1 square foot and examiner wanted us to convert it into square inches, then 1 foot is equal to 12 inches. Length and width of a tile is 12 inches. Side into side, 12 into 12, 144 square inches. Rectangle area. Area of a rectangle is base into height or length into width. If height is 3 and base is 5, we are fitting in small squares of 1 by 1 inside a rectangle, and we have 3 squares for width and 5 squares for base or what you call length. 3 into 5, it's 15. And visually we can see that there are 15 squares inside a rectangle. Parallelogram area. Now for a parallelogram, we have the same formula, base into height. So what's the logic behind it? If I cut a rectangle from this line and move it to this side, it's converted into parallelogram and the area is the same, so that's why we are using the same formula. Area for square is side into side. All sides are equal and we can write it side square. For an area of a triangle, we have an interesting story. Let's see what we can make with these two triangles. Two triangles can be joined to form parallelogram. And we know area of parallelogram is base into height. There are two triangles inside a parallelogram. This parallelogram is divided into two triangles. We have to calculate the area of one triangle. If the complete area of this parallelogram is this expression, base into height, then divide this area by 2 and we can have the area of a triangle. So this is the logic behind a formula of triangle. This segment is said to be the altitude of triangle. It's originating from the corner and is perpendicular to the opposite side. It is also known as the height of the triangle. If you have to figure out the length of this segment, then how can you do it? First, let's calculate the area of this triangle. Ignore this for the time being. Base is 4, height is 8. Applying the formula, the area of this triangle is 16. Now, rotate this triangle so that the base is 10 and height is x. Applying the area formula again, 1 over 2 base into height. Now height is x. This is another expression for area. These two areas are equal and we can equate these equations to get the value of x. When you have to find the area of an equilateral triangle, then you can use this formula. We can prove it how we derive to this formula, but right now remember this formula. Knowing just the length of a side, you can find an area of this triangle. For an isosceles triangle, we have to find an altitude of this triangle. We know that this altitude divides the base into two equal parts, and two right triangles are there. So for this triangle, the base is 3 and hypotenuse is 4. Inserting values in Pythagorean theorem, we have the value of height. Then applying the area formula, half base into height, area is 3 under root 7. Which of these shapes are trapezoid? At least one pair of opposite sides must be parallel. It's up to you. Answer this question. Area of a trapezoid. The parallel sides of trapezoid are called bases. This side has a length b1 and the upper side has a length b2 and height is h. Now there is another interesting story. Let's have another identical trapezoid, rotate it and join it with this trapezoid. Voila! Two trapezoids join to become a parallelogram. That's interesting. Now write a formula of area for this parallelogram. Base into height. Base is b1 plus b2 and height is h. If we want to measure the area of this one trapezoid, then we can divide this expression by 2 because this one trapezoid is half of this parallelogram. And in this way, we have a formula for measuring area of a trapezoid. Here comes a question. Find the area of this trapezoid. Values are given. Use a formula to find an area. Do it by your own. Rhombus area. Rhombus is a quadrilateral where sides have same length. And rhombus is also a parallelogram. With the same pattern of parallelogram, we can write area of rhombus is side into height. This is one way of finding an area. Let's find area with diagonals of rhombus. The diagonals of rhombus always intersect to form 90-degree angle. Let's label this horizontal diagonal as x and vertical diagonal as y. Rhombus has 4 equal triangles and we can move these two triangles to form rectangle. And this rectangle has the same area as rhombus. Now this side is x over 2 as it is half of x and length of another side is y. So area of this rectangle is y into x over 2. We can rearrange it x into y divided by 2. This is exactly the area of the rhombus because we made this rectangle with triangles of rhombus. Hence we got a formula for area of rhombus where x and y are the diagonals. If you know the two diagonals of rhombus, can you find the area of this rhombus? The measure of diagonals are given and you have to calculate the area. With formula, just insert the values. Any unit could be there in exam and write it properly. Centimeter square or square inches. Another question. Area of rhombus is 24 square inches. Length of one diagonal is 6 inches. What is the length of another diagonal? We can use this formula because we have the variables for both diagonals. And we can calculate the value of the missing diagonal. Area is given 24. One diagonal is 6. Missing diagonal divided by 2. Value of the missing diagonal is 8 inches.